Imagine a force, vast and unseen, tugging at the edge of everything we know. Far beyond the shining planets, past the drifting ice of the Kuiper Belt, something lurks in the darkness. Not a star, not a comet, not a wisp of gas. Something massive, something patient. A hidden giant, shaping the frozen outskirts of our solar system without ever revealing itself. We can't see it. We can't touch it. But the scars it leaves are written in the sky. Tonight, we follow those scars. Tonight, we hunt for a world that may yet rewrite the story of our solar system. This is the search for Planet 9. Buckle up. The first whispers. It began with anomalies. Distant objects beyond Neptune, small, icy bodies at the edge of the solar system, showed strange, clustered orbits. Their paths weren't random. They were tilted, aligned, as if nudged by an unseen hand. Astronomers like Konstantin Batygin and Mike Brown noticed the pattern. The probability of such alignment happening by chance? Less than 0.1%. Something massive had to be out there, herding these objects into place. Not a minor comet, nor a hidden asteroid, but a true giant. Estimates suggest Planet 9 could be 5 to 10 times the mass of Earth, orbiting the Sun from a staggering distance of 400 to 800 astronomical units. So far that sunlight itself would take days to reach it. In this frozen frontier, Planet 9 would move slowly, tracing an immense, elongated orbit that would take thousands of years to complete one revolution around the Sun. It would be so distant, so cold, that traditional telescopes would barely catch a whisper of its presence. Yet its gravitational influence, though faint, would be undeniable. A distant conductor in a silent symphony. And so began the search. A hunt not for what could be seen, but for what could only be inferred. By following the ghostly choreography of the solar system's outermost members. A hidden architect. A missing piece of the cosmic puzzle. Waiting in the shadows. Following the trail. Finding Planet 9 is not as simple as pointing a telescope into the darkness. It is a quest that demands patience, precision, and a deep understanding of celestial mechanics. The search begins by mapping the strange orbits of distant Kuiper Belt objects. Their paths, tilted and elongated, serve as signposts pointing toward the hidden giant. Using simulations and models, astronomers predict where Planet 9 should be, calculating its probable orbit based on the gravitational fingerprints it leaves behind. These models are breathtaking in their complexity. They account for the slow precession of orbits over millions of years, the gravitational nudges from other giant planets, and the chaotic influences of passing stars during the solar system's early youth. To model the possible orbit of Planet 9, scientists use massive computer simulations, adjusting parameters like mass, distance, and orbital inclination, and watching how the simulated Kuiper Belt responds. It's a delicate cosmic dance. Change Planet 9's mass by just a fraction, and the entire choreography of distant objects shifts. Some models suggest that Planet 9 might be inclined at a steep angle relative to the rest of the planets, orbiting like a sentinel on a tilted plane. Others propose that it could be in resonance with Neptune or Uranus, locked in a slow, gravitational embrace across billions of miles. And then there is the question of how long ago Planet 9 migrated to its current orbit. Was it cast out in the chaos of planetary migration? Was it always lurking on the edge, a distant hermit planet? Each scenario paints a different portrait of our solar system's turbulent youth, and each hints at how fragile the balance of worlds truly is. But the region Planet 9 may inhabit is vast. A single patch of sky where Planet 9 might hide could be hundreds of times larger than the area covered by the full moon. And Planet 9, if it exists, would shine so faintly that it would blend seamlessly into the background noise of the cosmos. Astronomers must sift through millions of tiny points of light, searching for one that moves just slightly, just enough to betray its presence. Powerful observatories like the Subaru telescope in Hawaii scan the heavens, capturing wide fields of view with incredible sensitivity. Automated algorithms comb through the data, seeking tiny motions over days, weeks, months. And still, no definitive image has been found. The hunt continues, patient and methodical. Every new discovery of a distant object, every new piece of orbital evidence refines the search. Every anomaly is a clue. Every silence is a challenge. Somewhere out there, hidden among the stars, a giant may be waiting. But the search isn't just confined to professional observatories. Citizen scientists around the world have joined the hunt, poring over archival telescope images, frame by frame, pixel by pixel, in hopes of spotting the faint wanderer. Even spacecraft like NASA's WISE, the Wide Field Infrared Survey Explorer, have provided vital data. Though not originally designed to find distant planets, its sensitive infrared eyes have helped rule out large swaths of the sky where Planet 9 is not. The process is slow, like assembling a puzzle with most of its pieces missing. But each constraint, each negative result, narrows the possibilities. Each failure brings us closer to the truth. Because sometimes, in the grand game of cosmic hide-and-seek, it is the empty spaces that tell us where to look next. Clues in the shadows. Even without a direct image, the evidence for Planet 9 grows stronger. Far-off objects in the solar system don't behave the way we expect. They cluster. They tilt. They point in similar directions, as if shepherded by an unseen hand. Some objects have orbits so extreme that they can't be explained by the gravitational pull of the known planets alone. These anomalies are not random noise. They form patterns. Patterns too consistent, too persistent to ignore. One of the most striking clues is the existence of so-called detached objects. Bodies like Sedna and 2012 VP113. Their orbits swing far out into the deep solar system, beyond the reach of Neptune's influence. Yet they return, pulled back by something unseen. Take Sedna, for instance. Its orbit stretches out to nearly 1,000 astronomical units, far beyond the Kuiper Belt. A single journey around the Sun takes Sedna over 11,000 years. Its path is too vast to have been shaped solely by the known planets. Likewise, 2012 VP113, nicknamed Biden, follows an elongated orbit with the closest approach still well beyond Neptune. Together, these distant objects hint at a gravitational force sculpting the outer reaches of our solar system. Then, there are the extreme trans-Neptunian objects, like 2015 TG387, nicknamed the Goblin. Its orbit is similarly distant and elongated, pointing once again to the possibility of a hidden giant influencing their paths. Each of these icy wanderers adds a piece to the puzzle, a whisper in the darkness suggesting that we are missing something important. Planet 9, if it exists, would explain these anomalies elegantly. It would account for the clustering of orbital paths. It would explain the strange tilts and the distant wanderers. And it would unify 100 scattered mysteries into a single coherent picture. But science demands rigor. Every alternative must be explored. Every possibility must be tested. Could the clustering be a coincidence? A trick of limited data? Some astronomers argue that observational bias, the tendency to find what we are looking for, might explain the patterns. Others suggest that a collective influence of many small objects, rather than one large planet, could shape the outer solar system. Still, the consistency of the evidence continues to point towards something more. A hidden hand, a missing giant, waiting to be found. Ghosts beyond. Neptune. As astronomers continue to search, new discoveries emerge from the twilight beyond Neptune. The Kuiper Belt, once thought to be a simple ring of icy debris, now reveals a deeper, stranger structure. Scattered disk objects, detached objects, extreme trans-Neptunian objects. Each carries a story written in ice and stone. Some trace wild, elongated orbits that defy easy explanation. Others linger at the very edge of gravitational influence, balanced delicately between the Sun and the stars. The most distant known object, nicknamed Farut, orbits the Sun at a staggering 120 astronomical units. And beyond even that, Farfarout, discovered in 2018, pushes the boundary to over 130 astronomical units. These frozen wanderers are messengers from the outermost reaches, each one whispering hints about the forces that shaped their paths. They move slowly, tracing lazy arcs across the sky over centuries. Their orbits are clues, their existence a mystery. Some, like 2015 RR 245, have highly elliptical orbits that hint at past encounters with a massive object. Others, like 2004 XR 190, nicknamed Buffy, show unusual inclinations, tilted well above the plane of the solar system. Each anomaly begs a question. What unseen influence sculpted these paths? Planet 9 offers a compelling answer. Its gravity could explain the clustering, the tilting, the strange distant wanderers. But even if Planet 9 eludes detection, these ghostly objects are valuable in their own right. They are survivors, ancient relics from the solar system's chaotic youth. Their icy surfaces record a history written not in words, but in orbits and scars. By studying them, we peel back the layers of time, glimpsing an era when planets migrated, stars passed close, and gravity wove a tapestry of cosmic change. The ghosts beyond Neptune are not silent. They speak, if we learn how to listen. And perhaps, if we follow their whispers far enough into the dark, we will find the hidden giant they hint at. What if Planet 9 is found? The discovery of Planet 9 would change everything. It would expand the known architecture of the solar system, adding a new giant to the celestial family. It would confirm that the solar system's frontier is far vaster and more dynamic than we ever believed. Planet 9 would also open a new chapter in planetary science. Its composition, its atmosphere, its temperature, and its history would offer priceless insights into the formation and evolution of giant planets. Was Planet 9 formed close to the Sun and later ejected outward by gravitational encounters with Jupiter or Saturn? Or was it captured from another star during the Sun's youth, when our solar system floated through a crowded stellar nursery? Each possibility tells a different story about the early chaos of the solar system's birth. Studying Planet 9 could also help us understand exoplanets, the thousands of worlds we've discovered orbiting other stars. Many exoplanetary systems seem to host distant, massive worlds. Finding and studying Planet 9 would give us a close-up example of these mysterious types of planets, bridging the gap between our solar system and the strange architectures we see elsewhere in the galaxy. And perhaps most thrilling of all, Planet 9 could have moons of its own. Tiny frozen worlds, orbiting in the dark, waiting to be discovered. A whole new system, hidden within our own. A silent kingdom at the edge of the sun's domain, waiting for the moment when the curtain of darkness is finally pulled back. Imagine the first images of Planet 9. A pale, frozen giant set against a backdrop of distant stars. Imagine the first mission proposals, daring journeys to study its surface, its atmosphere, its satellites. Imagine what new mysteries it might reveal. Unknown chemistry, unexpected geology, clues about the building blocks of planets across the universe. Planet 9 could become a new frontier, a beacon for future generations of explorers. A reminder that even in the modern era, when maps seem complete and skies thoroughly charted, the universe still holds secrets, waiting, patient, in the dark. The endless hunt, even as the years pass and no direct image is captured, the search for Planet 9 continues. Because science, at its heart, is an act of hope. Hope that the universe still holds secrets waiting to be found. Hope that through patience and perseverance, we can reveal the unseen. Every new survey, every new algorithm, every new generation of telescopes brings us closer. Technologies like the Vera C. Rubin Observatory, with its unprecedented sky mapping power, promise to push the limits of discovery even further. If Planet 9 is out there, Rubin's deep, wide, and fast survey could be the key to finally spotting it. Perhaps Planet 9 is just too faint, too slow, too cleverly hidden among the stars. Or perhaps it doesn't exist at all, and the anomalies we see are the signatures of some new, unknown physics. Either way, the search matters. Because, in searching, we learn not just about the distant corners of our solar system, we learn about ourselves, about our relentless curiosity, about our refusal to accept that all the great frontiers have already been conquered. Planet 9 remains a phantom, a dream drifting at the edge of our understanding. And until we find it, or prove that it isn't there, we will keep looking. Because to search is to believe. And to believe is to reach, even into the dark. The legacy of the search. Even if Planet 9 remains forever hidden, the search itself leaves a profound legacy. It reminds us that discovery is not only about reaching the destination, it is about the journey, the questions we dare to ask, the boundaries we dare to push. In looking for Planet 9, we sharpen our tools, we refine our methods, we deepen our understanding of gravity, of cosmic evolution, of the delicate clockwork of the solar system. The pursuit draws generations together, students and scientists, amateurs and experts, all connected by the ancient universal urge to look up and wonder. It is a legacy of curiosity, of perseverance, of never being satisfied with what we know. And even if the shadow we chase proves to be an illusion, The paths we blaze in chasing it will open new frontiers, revealing new mysteries, inviting new dreams. The search for Planet 9 is not just about finding another planet. It is about reaffirming who we are. A species defined not by where we are, but by how far we are willing to go. If Planet 9 is out there, we will find it. And if it is not, the search itself, the questions we ask, the mysteries we chase, will still illuminate the vast, intricate wonder of our cosmic home. Because in every whisper of gravity, in every distant speck of light, the universe invites us to explore. If you enjoyed this journey, let us know what mysteries you'd love to explore next. Leave a comment below. And don't forget to like, subscribe, and join us for the next voyage into the unknown.